In considering the role of the individual in society when confronting conflicts about the GMO, it's useful to recap a bit before we go there. We first considered the utility of genetic engineering in agriculture for plant scientists, breeders, and farmers. We then confronted a kind of paradox. If there's so much utility and such useful kinds of technology, then why is there so much opposition globally? That led us to consider general objections to the technology and then specific objections, such as contested science on risk, role of small farmers in the biotech adoption story, and then corporate control of agriculture, and the more fundamental objection that GMOs are themselves fundamentally unnatural. And so when we think through these things, we think there's some clarifications that are really valuable for coming to decisions that we can all feel comfortable about for the individual and for society. And the first of those is that not all GMOs are the same, right? So just like not all chemicals are the same, you'd want to distinguish by what the chemical's used for, how dangerous it is, how risky it is, how you regulate it. And with GMOs, they have very different purposes. So among people who think about this issue, there are lumpers who say all GMOs are the same, and there are splitters, tend to be scientists, farmers who want to know what specific trait produced by what specific genetic event in what specific crop and in what kind of farming system. So those kind of complications make it very difficult for us to talk generically about GMOs. That means we have to disaggregate. By disaggregating, we think about all of these differences and compare them to each other, to the alternatives. So we'd have different alternatives to different kinds of GMOs used in specific instances.
Right, okay. So this concept of disaggregation, that sounds really useful, but also pretty complicated. Can you say a little bit more, maybe give us an example about what you mean by that?
Yeah. So, I mean, everyone talks about golden rice. So this is biofortification. It's used to address micronutrient deficiencies. But in agriculture, one of those common things is Bt crops. They carry a transgene that makes them control certain insects. An alternative to a Bt crop is spraying organophosphates or some other kind of insecticide on the field, or organic farmers use the Bt bacteria or its products itself and spray it onto the crop rather than having the crop produce it from inside its own cells. Or you could just give up on the bugs and let them have their share of the crop. That's another possibility,
Sure, that's
an alternative to
yeah.
using the GMO. To take a different GMO, you think about the virus-resistant papaya that we'll be discussing at length. The balance is harder to calculate because there's no real alternative to using the virus-resistant technique. Farmers would actually cut down the papaya trees or clear forest and just start all over, planting in a different place. So in each case, we want to see what are the alternatives to use of the GMO so that we can come to some kind of balance of the benefits and the objections.
Right. So as we disaggregate the arguments and the objections, we naturally seek a way to make a decision in order to weigh GMOs against the alternatives. And I think it's pretty tempting here to try to pull out a scale and just weigh the balances, right? So I have my orange here and I have some duct tape here. I just want to weigh these, right? And I want to be able to see a weight and make a decision on that. But that doesn't work, does it? Because these two objects, they lack a common numeraire. Even if one's heavier, that doesn't necessarily make it better. If I think about farmers who are trying to come to these decisions, they want to be able to pull data from existing field trials, practices that they've done in the field, and come to a decision based on that. But again, would farmers want to make that decision based on just which is less expensive, which is more effective? What if one's locally produced on the other? How do we take all of these different data points together and find a common metric for them?
It's even harder than that because different people will have different notions of what's important. As you said, farmers may have a different notion from urban consumers.
Right.
So if you're taking a different metrics for looking at GMOs, you run into kind of insoluble comparative questions. Worse yet, for many people, there are deal breakers in their objections to GMOs.
Deal breakers, yes. This is a really interesting concept. What do you mean by deal breakers?
Well, it applies to an objection which is so fundamental that it overrides all benefits and all other objections. So it's not comparing across objections and benefits, it rather trumps everything else. This means that there's no common ground. I'll give you a couple of examples. So suppose something is produced by Monsanto, or something is considered unnatural, that the whole process is unnatural. Then the benefits are irrelevant because an unnatural thing may be unacceptable in certain kind of theological or ideational sorts of configurations of the world. And if that's true, you and I can't talk about it because we have different notions of what's natural and unnatural. For me, it's really hard because I think of bacteria and viruses as being completely natural, but they kill our crops, they kill children, animals, ourselves. We don't think of them being benign just because they're natural. So human beings do intervene continuously in ways that make the natural more amenable to human interest.
So even though you and I have different definitions potentially of natural and unnatural, and this week we're going to try to look for ways that we can find common ground to have a constructive dialogue about these issues. We may still have different objections, but
That's right.
How can we move forward?
That's right, and so that's why we come at the end of the course, we come back to the notion of what social scientists call social choice theory. This is how social scientists think about solving problems of different interests, different ideas, and different positions of individuals in societies. This becomes more complicated with the GMO because not only do you lack a common metric, but there are societies stretching from the very local to the national to the transnational. So that, for example, Europeans have a lot to say about what crops can be grown in Africa, but Africans don't have a lot to say about what crops can be grown in Europe.
Right.
And with this transnational advocacy, with global science and global technology, and the difficulty of weighing these objections, the absence of a lot of common ground, you can see why the politics of the GMO is so fascinating, but also so difficult.